Assalamualaikum warahmatullahi wabarakatuh. Uh, hello to my lecturer. My name is Muhammad Fariduddin bin Muhammad Shaed. Metric number 191091051. I'm from Group 2. I will discuss about my project simulation and problem solving. For introduction, three-phase electric power is a common method of alternating current electric power generation, transmission and distribution. It is a type of polyphase system and is the most common method used by electrical grids worldwide to transfer power. It is also used to power large motors and other heavy loads. A three-wire, three-phase circuit is usually more economical than an equivalent two-wire single-phase circuit at the same line to ground voltage because it uses less conductor material to transmit a given amount of electrical power. Polyphase power systems were independently invented by Galileo Ferraris, Mikhail Dobrovolsky, Jonas Wenstrom, John Hopkins, and Nikola Tesla in the late 1880s. The project simulation assignment has been assigned to the student of EET 208, Electrical Power Technology, especially to increase our understanding on three-phase system and also to help us using software simulation. We are given to construct a three-phase Y-connected generator to Y-connected load, along with a transmission load and a balance load determined by our metric number. We need to investigate and analyze the electrical system given, evaluate and analyze the parameter. We also need to stimulate this situation on software simulator with guidance of Electrical Supply Application Handbook (ESAH). For objective of this project is first is to investigate the electrical system that consists three-phase Y-connected generator, transmission and load. Second is to evaluate the parameters of the electrical system in the context of transmission and load impedance, currents, voltage and acceptable voltage drop. Third is to evaluate and analyze the active power absorbed by the load by using 2 wattmeter method and the conventional measuring method. For methodology of this project is there are two methods that are used for this observation: calculation and PSIM software. Calculation is used for calculate the voltage drop of the electrical system, while the PSIM software is used for simulating the circuit and analyze the load impedance, current and voltage of the electrical system. What is PSIM? PSIM is an electronic circuit simulation software package designed specifically for use in power electronic and motor drive simulation but can be used to simulate any electronic circuit. Developed by PowerSim, PSIM uses nodal analysis and the trapezoidal rule integration as the basis of its simulation algorithm. PSIM provides a schematic capture interface and a waveform viewer SimView. PSIM has several modules that extend its functionality into specific areas of circuit simulation and design including control theory, electric motors, photovoltaics and wind turbines. PSIM is used by industry for research and product development and it is used by educational institution for research and teaching. This is the icon of PSIM software. Result and discussion. For the result, we use PSIM software to build the circuit. This is the circuit of the project. First is we use 11 kilovolt for V line to line and 50 hertz of 50 hertz of the frequency. For line 1, line 2 and line 3, we use 51 we use resistor 51 ohm and 0.032 for inductor. For line load, line 1, line 2 and line 3, we use 91 ohm for resistor and 0.029 inductor for the 1, 2 and 3 load, line load. For measuring the current at the line, we use voltmeter and put at at line 1, line 2 and line 3. For measuring the volt at the line, we put the voltmeter between line 1 and line 2 and line 2 and between line 2 and line 3. For measuring the voltage at the at the voltage load, we put voltmeter in front of the line at line 1, line 2 and line 3. For the result, we must run the simulation. This is the result of the when we simulate the circuit. Here is the graph of I1, I2 and I3, and this is the value of the I1, I2 and I3. To find the V drop, we use calculation. For the calculation, um, first is we use the formula of V drop. V supply minus V load divide by V supply multiply by 100%. For if for ZL, I got 91 plus 9J. For ZT, I got 51 plus 10J. For billet, we use 11 kilovolt as I get at the rubric. Next is we find V phase 11 kilovolt divide by square root 3. Then the answer is 6.35 kilovolt. Next, we find IAN, IBN, and ICN. For IAN, I get 44.32 and negative 7.62 degree. For IBN, I get 44.32 negative 127.62 degree. For ICN, I get 44.32 and 112.4 degree. So IL is equal to I phase. For V-load, the formula is IAN multiply by Z1, and I got for 40 452.8 and 5.648 degree. Veloute A, veloute B, and veloute C is the same. For 1052.8 and 5.648 degree. We put in the formula we drop. We supply, we get 6.35k kilovolt minus 4052.8 and divide by 6.35k kilovolt um, and multiply by 100%. So I get the answer for withdrop is 36.18%. For the conclusion, the conclusion is first we can investigate the electrical system that consists three-phase Y connected generator, transmission loss and a load. Second, we can evaluate the parameter of the electrical system in the context of transmission and load impedance, currents, voltage and acceptable voltage drop. Lastly, we can evaluate and analyze the the active power absorbed by the loads by using 2 wattmeter method and the conventional measuring method. That's all. Thank you.